Hi, I'm Steven.
I'm Grace,
I'm Herschel.
and we're from Team DERP. Our project is Steganography, which is the process of encrypting images into other images by overlay. So we have two basic functions, the expand function and the flatten function. The expand function first multiplies the value of the logical array that is extracted by 255, which gives light values that MATLAB can actually display. And then our flatten function checks the light value of the C data array and converts it to a logical array. Then the output array is passed into one of the two encrypt functions. So our first encryption function is the basic even or odd encryption, and it first evens out all the bits in the original layer by taking all the pixels decimal value and dividing by 2 and then multiplying by 2 again. And then we use floor so that we don't max out the original pixel value. And the floor is called after the division. And then we take the encrypted bits and we change them to be odd in the original image so that we encrypt the encrypted or image to be encrypted into the original image. And this method is very easy to implement and it's very easy to understand. However, it's very inefficient because we can only encrypt one image per layer.
So the next two functions I'd like to talk about are called encrypt bitwise and add image. So all encrypt bitwise does, it gets the layer and the bit position in which you want to encrypt the image in, and then calls add image with this knowledge. So what add image does is that it converts the decimal pixel value to binary, shifts the binary number to the right, however many bits you want it to go, changes that pixel to odd or even depending on what the encrypted image says, and then moves it all the way back. So for example, if the decimal value is 129, it's in the first layer, and the third bit is to be modified, and the third bit needs to be odd. We shift this binary number to the right, add a 1 here, and then convert it back to decimal, and then pass it back as the output, which is the encrypted image. To decrypt any of these images, we just need to tell it what layer and what bit that we're going to decrypt from. So what this does is something similar to encrypt bitwise. It shifts the bits, binary bits, to the right, reads it. So let's say if we want to decrypt the third bit, shifts this to the right, so this 1 is now the rightmost bit, and it reads the bit and sees if it's odd or even, and it passes back a logical array telling MATLAB what the image actually is.
So this is how the GUI works. First we run this. This is our GUI. So the first part where you want to load in the main image right here. Then you scroll down and find your main image. Open it and it will pop up right here. Then you load your next image, the one you want to embed. And load that. Now you choose which encryption method you want. So let's say you want to do odd even on the red layer, and this is your encrypted image. Now here you have several choices. Either one, you can load an encrypted image that you have and load it here and then decrypt it, or you can send this image back to recrypt right here. You can decrypt this image, or you can download this image. So let's send this back to recrypt, and then let's load another image right here. Let's call it Doom2. Open, and let's embed with the second method. Sometimes there's some lag, so wait. And then now let's decrypt this to however many. There's an automatic decryption method, so however many images are encrypted, it will automatically be decrypted and will pop up in new figures. Finally, you can download and save. So I could save this as any type of file in the MATLAB path.